Today, I want to highlight a terminology issue that often get confused in prediction. I have no disclosure. The terms risk and probability are frequently used interchangeably, and sometimes within the same article, same paper. For example, here for lung cancer, we know that the PLCO model is a risk prediction model. It takes on patient information and predict lung cancer risk within the next 6 years. And on the right-hand side is the Brock model or the Pankheim model. It actually is a nodule malignancy model. So a lot of times the Brock model is often described in using the language of risk, but in practice it's more appropriate to interpret it as a probability that a nodule is malignant. So risk and diagnosis probability are not interchangeable. A risk model asks who will develop disease later among people who are currently disease-free. And for a diagnostic probability model, asks who already has a disease now, and disease may already be present but unrecognized or very subtle. So if we are looking at a CT scan, and our findings here on the left-hand side, any time period here before the disease developed, we're talking about risk model. But if we're using a CT scan right after the, on the right-hand side when it gets a little red, even though before the nodule, you can see the nodule there, we're talking about a probability model. So the distinction and also apply to the big three here. So for acute event, stroke or myocardial infarction is usually a future relatively a discrete event. The baseline status is more often disease-free or event-free, and the risk prediction and diagnosis are therefore more clearly separated in time. But however, if we're looking at lung cancer, it's different. The disease may already be biologically present for years before the clinical diagnosis, and the baseline scan may already contain visible or subtle evidence of the lung cancer. And when we look at coronary artery calcification or emphysema, a lot of times we're quantifying, and the AI tools are quantifying the current severity of the disease. These output are prognostically useful, but these are not predicting new future events. So in summary, the boundary is clearer for acute event than in lung cancer for on CT. So confusion arises when the endpoints and labels blur these distinctions. Time of diagnosis may occur long before the biologic onset of the disease. Baseline images may already contain visible but subtle focal diseases, and apparent future prediction may partly reflect current but unrecognized disease, and severity quantification may be described as prediction even when it's primarily measuring current burden. So the same word prediction may refer to future risk, current disease severity, or a hybrid of things. So we have to be very careful and precise of what score we're actually representing. So the next one I want to talk about is AUC, which you have seen in a lot of these papers being reported. AUC can be very misleading and if we do not look at it carefully at the data structure and the endpoint. First, in highly imbalanced data, a model can pose a very high AUC even and still producing low or positive predictive value and many false positive action threshold. And so apparent performance may look stronger than clinically actionable. And then also you have seen papers such as Civil using reporting cumulative versus year-specific AUC. If the results are pulled over several years from baseline, later year performance may actually appear stronger than the true year-specific prediction, especially if the baseline imaging already contains disease signals that are expressed through the diagnosis over time. So here, I'm just briefly showing that here you can see that in the later year, even the year-specific AUC is 0.5, which means it's by chance alone. When you're looking at cumulative AUC, you can still get a pretty high reasonable AUC in the 0.7 or 0.8 range. So here for the metrics that we care about are also different when we talk about risk and diagnosis. For risk models, calibration and absolute risk matters. They do predict probabilities match observed future occurrence. Risk stratification should support screening eligibility and prevention decisions. But for diagnostic probability models, we're focusing on sensitivity, specificity, positive predictive value, and negative predictive value, and thresholds behavior are central. We care more about the workup burden, false positive, and missed diseases, and whether the action threshold are clinically acceptable. So AUC alone are not enough. It's rarely enough. So for when we're looking at risk, we care more about the future probability calibration. And for diagnostic probability, we care about the threshold performance and actionability. So I want to end with these three questions and I want all of us to keep in mind when we read these papers and look at these models. First is, what is the model actually estimating, whether it's future risk, current disease burden, or a mixture of these combination? Does the endpoint matches the clinical claim being made, and also are the reported performance metrics appropriate for that task and what is intended to use?